Welcome back. Last section of Unit 7, inverse trig functions, or ratios rather. So we're going to do basically the same thing we did last time with sine, cosine, and tangent. But now we're going to be finding angles. Alright, before we had all the angles and it was pretty easy. Now this is going to include finding the angles. Alright, now I'm not saying it's hard at all. Alright, what angle of elevation should Spider-Man sling his web up in order to hit the lizard? Well, Spidey's here, the angle of elevation, here's the horizontal, so this is the angle we're talking about. And a lot of times I use this Greek symbol theta. If you just like x, that's fine, alright? But we know this is going to be opposite, and we have adjacent, so what's opposite over adjacent? That's tangent. So the tangent of theta, or x, or whatever, equals 125 over 435. Now, we have theta here, and that's what we want to solve. So we have to undo it, all right? And that's what we're going to talk about today. All right, so quick reminder. We have sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent, otherwise known as SOHCAHTOA. All right, so to find these, we have to do the inverse or opposite. The inverse or opposite, let's take a look. Remember, if I'm solving an equation 2x equals 10, the opposite of multiply is divide, the inverse, all right? The inverse of tangent is what we call inverse tangent, all right? And if I do it to this side, I have to do it to this side. All right? And that cancels out, and that would give me theta equals the inverse tangent of 125 over 435. So let's take a look at that one. Remember, we have to be in degrees. Let's just check. I'm in degrees, so I'm good. I can quit. So I want to do second tangent. See, the blue is the inverse. All right? 125 divided by 435. So the angle would be 16.0 or 16 degrees. All right? So that one wasn't so bad at all. Hey, 16 degrees. All right? So let's try another one. All right. Oh, that's the one we just did. Duh. All right, so that was 16 degrees. All right, again, to find the inverse sine, inverse cosine, or inverse tangent, you have to use the second function key on that graphing calculator. All right, let's do one. So here's my angle I want. I have opposite and hypotenuse. That's sine. So sine of theta, or x, whatever you want to call it, is 30 over 36. So now, I know that what I'm going to do here is inverse sine of sine theta equals inverse sine of 30 over 36. Now, if you don't want to write this over here, you just want to write theta equals that, totally cool. And I'll probably do that the rest of the way as well, okay? All right, so let's see what we have on this one. All right, we have inverse sine, so second sine, inverse sine of 30 divided by 36. And we get 56.4, so to the nearest degree is 56. So 56 degrees. Why do you keep wanting to be a highlighter? 56 degrees. All right, there we have it. Let's do this one. We have adjacent and hypotenuse. Adjacent, that's cosine. So cosine x equals 36 over 54. So I'm going to undo it by doing the inverse cosine of 36 over 54. All right, plug it in, see what we get. Second cosine, 36 divided by 54. 36 divided by 54. And we get 48.1, so we'll call it 48. So x is 48 degrees. Let's do this one. Now we can do anything we want, right? Because we have all three sides. So what have we not done? We haven't done tangent. So let's do tangent. So tangent of theta equals opposite 48 over adjacent 36. So theta equals inverse tangent of 48 over 36. See what we get when we do that one? Second tangent, 48 divided by 36. 53.1 stays 53. Seriously? So theta is 53 degrees. Is that bothering anybody else or just me? Just me. Okay, great. All right, so let's see what else we got here. Oh, angle of depression. We talked about angle of elevation. Now we're going to talk about angle of depression. Angle of depression is a little bit trickier. All right, I'll show you why. An angle formed by a horizontal line. So here's my guy. Here's the horizontal line from him. Okay? And the line of sight to an object. So here's the line of sight. Here's what he's looking at. So the angle that's formed right there, that's the angle of depression. The reason I say this is tricky is because a lot of times, and I'll show you in a second, it would appear as though this should be the angle. And it's not. It's between the horizon, all right, and the line of sight. So let's do one and show you what I'm talking about. A jet is coming in for a landing. So let's say the jet's right here. I'll draw my worst airplane ever. That's awesome, huh? All right, so it's currently 25,000 feet in the air. So let's draw that line. That's perpendicular, so that's 25,000 feet. And the landing strip is 45,000 feet ahead. All right, so here's the line of sight. So right now you can see it would be easy for you to think that's the angle of depression. But you have to remember, this is the horizon. This is where he's flying at. All right? And I often use dotted lines. That's what the course he's taking. He wants to know how much does he have to go down from that, depress from that. So that's the angle we're trying to find. The nice thing is it's a rectangle. So that's 25, that's 25,000. If that's 45,000, this is 45,000. All right? So now we can find it. Opposite over adjacent. So tangent of theta equals 25,000 divided by 45,000. And get rid of these zeros, right? So inverse so theta equals inverse tangent of 25 over 45. Let's see what we get. Second, inverse tangent of 25 divided by 45. And we get 29.0, so 29 degrees. No highlighter. So theta is 29 degrees. Now, let's reflect. Are we answering the question? Will this be a safe landing? Well, 29 degrees, that doesn't answer that. In order to ensure a safe landing, the plane needs to come in at no more than 30. Is that more than 30? No, that's less. So yes, this is a safe landing. All right? So take a second, pause the video, try these on your own, come back and see how you did. Great. So here we go. I have opposite over adjacent, so that's tangent. So tangent x equals 17 over 30. So x equals inverse tangent of 17 over 30. All right, let's see what we get. Second, tangent 17 divided by 30. All right, 29.5. That means that rounds to 30 degrees. If we're trying to find nearest whole degree, so x is 30 degrees. Or here we can use any of them. Let's use, we haven't used sine in a while. So sine is opposite over hypotenuse. So sine x equals 18 over 82. So x equals inverse sine of 18 over 82. See what we get? Boom, shakalaka, 12.6, which is 13. So x, fine. X is 13 degrees. Seriously, hate the highlighter. All right, so that's the end of the Unit 7. Hopefully you knocked this section out because it's really close to what you've done already. It's just the opposite of that, which is not that terribly difficult, all right? Hopefully you're getting good at those sine, cosine, and tangent relationships. Best of luck on this master check and go kill that test.
The basis of this game seems to be simple geometry. All you have to do is hit the ball here.
I can't believe it. You've actually found a practical use for geometry.